Should we begin, guys? Those who are attending, just yes, please tell me. Okay, chalo, great. So, exercise number 4 is based on this formula. You may write this formula: limit x approaching towards a, x raised to n minus a raised to n upon x minus a is equal to n into a raised to n minus 1. N into a raised to n minus 1. Please copy this formula. Okay. Now, one example based on this: x approaching towards 3, x raised to, let's say, 7 minus 3 raised to 7 upon x minus 3. Okay, we have to write this now. Now compare, you just compare whatever is there in the formula. You just compare whatever is there in the formula and tell me what is n and what is a. What is n and what is a? Just tell me.
The 7 is N and 3 is A.
7 is n and 3 is a. Right, Anya. Good. So n into a raised to n minus 1. Now provided we have to apply the formula, provided there is no power for the terms in the denominator. See, in the denominator there shouldn't be any power. So x minus 3, x does not have any power, 3 does not have any power. But then in the numerator, the power should be same. The power should be same. Okay. So this becomes n. Power should be same. Okay. One more thing. There should be minus sign in middle. And the last thing, this a should be same. A, and A. All these things should be same. Minus sign in between. Denominator no power. Numerator should have a common power. Okay. Calculation part will be simple. It's just plugging the values. So n is equal to 7. A is 3. 7 minus 1. Okay. So whatever is the answer, you can just write it down. 7 into 3 raised to 6. Okay. It was a random example given to you. Now we'll start with actual problems. Okay. Yeah. So see, exercise number 4, which I have given to you all. Exercise number 4. I'll write down the question as well. So the first question over here is limit x approaching towards 1, x raised to n minus 1 upon x minus 1, right? Which can be further written as, okay. Now this one, this particular one, can I write it as 1 raised to n? Yes or no? Can I write it as 1 raised to n?
Yes, sir, because n 1 raised to any power is 1.
Correct. 1 raised to n is 1. Now you compare with the formula. Limit x approaching towards a, x raised to n minus a raised to n upon x minus a. It is n into a raised to n minus 1. N into a raised to n minus 1. Clear? Yes or no? So tell me what is n and what is a. Compare the given question with this formula.
Sir, n is n and a is 1.
N is n and a is 1. So n into a raised to n minus 1 So n into 1 raised to n minus 1. Now what is 1 raised to n minus 1? 1 raised to n minus 1 is 1. Okay. Yes. Any doubts, any issues in this particular problem? Someone keep on marking in the worksheets. Those who have the worksheets, please keep on marking. Okay. I'll directly take you to question number 7. Okay. Limit x approaching 0, x raised to 3 by 2 minus 27 upon x minus 9. Okay. Now see, they will not frame problem in any random manner. There will be some logic behind it. So this 27 now. Okay. And this is x approaching 9. Sorry. X tending towards 9 or x approaching 9. So this 27 is 9 raised to 3 by 2. Now how will it click that it is 9 raised to 3 by 2? Because denominator is 9 over here and there is 3 by 2 over here. Now let's check why 9 raised to 3 by 2 is 27. X raised to 3 by 2 is x root x. X raised to 3 by 2 is always x root x. How? X raised to 1 into x raised to half. 1 plus 3 by 2 is 1 plus 1 by 2 is 3 by 2. So x raised to 3 by 2 is x root x. So 9 raised to 3 by 2 is equal to 9 root 9. So 9 into 3, which is 27. Okay. So next step, I'll compare this with the formula. Limit x approaching a, x raised to n minus a raised to n upon x minus a, n into a raised to n minus 1, n into a raised to n minus 1. Fine. So who is n and who is a? Can someone tell me by comparing? Please tell me who is n and who is a?
N is 3 by 2 and A is 9.
N is 3 by 2 and a is 9. Perfect. So n into a raised to n minus 1. So 3 by 2 into 9 raised to 3 by 2 minus 1. So 3 by 2, 9 raised to 3 by 2 minus 1 is 9 raised to half. Okay. 9 raised to half. So 3 by 2 root 9. Root 9 is 3. So this is 9 by 2. So this is 9 by 2. Okay. So that was your question number 7. Let's go to question number 8. Let's go to question number 8. Okay. So limit x approaching towards a, x root x minus a root a upon x minus a. Now sometime back, in the previous problem, I told you something. What is x root x, guys? What is x root
X is
x?
to half.
So x 3 up.
X raised to 3 by 2. Correct. X root x is nothing but x raised to 3 by 2. Okay. Yes or no?
Yes, sir.
Great. So minus a raised to 3 by 2 upon x minus a. Upon x minus a. Fine. Compare it with the formula. A, A and A. Minus minus in between. Denominator does not have powers. This is n. 3 by 2 is n. Okay. So A is nothing but A. N is 3 by 2. If you compare with the formula. Right. So n into a raised to n minus 1. N is 3 by 2. A raised to 3 by 2 minus 1. 3 by 2 minus 1 is nothing but A raised to half, and A raised to half is root A. A raised to half is root A. Guys, any queries in this? Guys, I just need a feedback. Are you able to understand this?
Yes, sir.
Yes, sir.
Is it easy or difficult?
This part is easy.
Okay, great. So this was question number 8. Let's go to question number 10. We'll solve question number 10, 11, and 12. Question number 10. Limit x approaching towards minus a, x raised to 9 plus a raised to 9 upon x plus a. Okay. Now here, this is equal to 9. This is given. We're not proving it is 9. They are saying if this value is equal to 9, we need to find out the value of a. Okay. Now, first of all, the formula cannot be applied because there is minus sign in between. Sorry, plus sign in between. Because there is plus sign in between. We need to have a minus sign in between. Why? Why I said so? Because the formula is limit x approaching towards a, x raised to n minus a raised to n upon x minus a. So in the formula itself, there is a minus sign. So we need to get rid of this minus sign. At the same time, it is minus a over here, but then here it is a. Okay. So look at the manipulations. How we need to proceed with this. Okay. So this is x raised to 9 plus down. First, I will write x minus minus a. In the denominator, I have written x minus minus a. Is it mathematically valid to write x minus minus a?
Yes, sir.
Yes, sir.
It is. It is because see, we require minus over here in the denominator, and minus minus is plus. So x minus minus a. And here also, I'll write minus minus a raised to 9. Okay. Look at the manipulation. Now, guys, tell me. I just want to know from you. What is minus a the whole raised to 9?
Minus a raised to 9.
Minus a raised to 9, because minus raised to 9 is minus and a raised to 9 is a raised to 9. Okay. So this minus along with this minus makes this plus. Anyone has any confusion? Anyone has any confusion?
No,
Okay.
sir.
Yeah. So this is the adjustment which I have done. And then I will proceed. Now I'll compare with this formula. Now it's easy for us to compare. So a is minus a and n is 9. So n into a raised to n minus 1 equal to 9. So n is 9. A raised to 9 minus 1 is equal to 9. 9 and 9 cancel. Therefore, a raised to 8 is equal to 1. Okay. So minus 1 raised to 8 is also 1. And plus 1 raised to 8 is also 1. So what is a? What is a?
So 1.
Plus minus 1. No? Yes or no? Because 1 raised to 8 is also 1. And minus 1 raised to 8 is also 1. So a is equal to plus minus 1. Guys, you are able to understand this. You can ask doubts in this problem. There is no need to worry.
So
Please ask doubts.
should do we also take the complex roots of this, or like do we just not take them?
Don't take the complex. Guys, please ask doubts because the first step itself was not so easy. This particular step, conversion of this into this. Why we have done certain things and then the changes that we have done. If you are getting confused anywhere, you please ask. I will teach this once again. Not really a problem.
So can you explain the second step?
Sorry?
Can you explain the second step?
Yes, why not? Sure. So, see, the problem is like this. Limit x approaching minus a, x raised to 9 plus a raised to 9 upon x plus a equal to 9. Now, see, the formula is limit x approaching towards a, x raised to n minus a raised to n upon x minus a. Don't we require a minus sign in between to apply the formula over here? In the question, don't we require a minus sign? Yes or no?
Sir,
Hello. Somebody was asking, no? So don't we require a minus sign in between?
Yes.
Correct. So we have to make that minus, and at the same time, there is one more challenge over here. This is minus a, but then unfortunately, these two are plus a. So we require two things. We need to make this minus signs over here, and we need to make this minus a over here. Okay. Yeah. So now see how we are doing that. Right hand side is 9. We don't have to do anything with the right hand side as of now. Okay. So limit x approaching towards minus a, x raised to 9. First we'll manage the denominator, x minus minus a. So two things we got. We got minus sign in between and we got minus a over here. But then is this mathematically valid? Yes, because minus into minus is plus. So this is written in this format. Do you agree with me?
Yes.
Great. Now see. Now numerator. This plus has to be paid minus. Okay. So there will be changes happening over here, a raised to 9. So it will be written as minus a raised to 9. Okay. Now see, x raised to 9 minus, what is minus a raised to 9? Minus a, the whole raised to 9 is what? It is minus a raised to 9. So this minus and this minus is this plus. It's mathematically valid to write in this format. I hope you got the point right now.
Yes.
So now apply the formula. N is 9. If you compare with the formula, a is minus a. So n into a raised to n minus 1 is equal to 9. What is n? 9 minus a raised to n minus 9 equal to 9. 9 and 9 cancel because there was multiplication. Okay. Minus a raised to 8 is equal to 1. So a raised to 8 is equal to 1. Okay. Minus raised to 8, it's a even power. So negative 1. A raised to 8 is equal to 1. Right. Now when something raised to 8 is equal to 1. So a is equal to plus or minus 1. Because 1 raised to 8 is also 1 and minus 1 raised to 8 is also 1. I hope that clears your query.
Yes.
Okay. Question number 11. X approaching towards a, x raised to 5 minus a raised to 5 upon x minus a. Now this is very simple and straightforward. It does not require too much of analysis. N is equal to 5 and a is a. So n into a raised to n minus 1, 405. See, we are having a same, minus sign in between, powers in the numerator, no powers in the denominator. We can apply the formula. So what is a? Is n is 5, a is 5, a, and this is 5 minus 1 equal to 405. So a raised to 4 is equal to 405 upon 5. That is 81. Okay. So this is 3 raised to 4. Okay. Right. It also can be minus 3 raised to 4. It can be 3 raised to 4 or minus 3 raised to 4. Because minus with an even power will give you a positive answer. So 3 raised to 4 is also 81 and minus 3 raised to 4 is also 81. So A is plus minus 3 by comparing. Guys, any doubts in this particular problem? Those who are attending? Any
No,
doubts?
sir.
So why? How do you get -3?
Negative value.
3, na?
Acha, now see, Siddhant, minus 3 into minus 3 into minus 3 into minus 3 is what?
Yeah, 81 only.
81 only. So 81 can also be expressed as minus 3 raised to 4. Na?
Yeah, okay, sir.
See, whenever there is even power, na, you can put plus minus. Odd के लिए ऐसा नहीं होता. Correct? In even power, negative sign goes. Okay, so that was question number 11. Question number 12, you can take it for self-study. I'll take one extra problem. Limit x approaching towards 2, x raised to 8 minus 2 raised to 8 upon x raised to 5 minus 2 raised to 5. My first question to all of you is, can we apply the formula?
No, sir.
You can't apply formula, sir.
So you have to.
Yes, now many people are saying we cannot apply the formula, correct? But then what is the reason behind it?
Sir, because 8 is not a multiple of 5, but you can apply that.
The exact reason is there is powers in the denominator also. You got the point? In the formula, do we have powers in the denominator? Yes or no, guys?
No, sir.
Yes, sir.
Also,
Yes, somebody said yes. In the formula, I'm saying. In the formula, there is no
No,
powers in the
sir.
denominator.
Don't have.
Okay, yeah. So now how to handle these problems? Let's see. Okay. Now x raised to 8 minus 2 raised to 8. We'll divide this by x minus 2. And the denominator also will divide by x minus 2. So in short, we are dividing all the terms by x minus 2. You cannot just divide the numerator. If you're dividing the numerator, you'll have to divide the denominator so that it gets cancelled. Okay, but then don't cancel, obviously. Yeah. So here in the numerator, what is n? Now we can apply the formula up and down. Come on, tell me, what is n? What is n?
8.
8 and
What is a?
2
Denominator, what is n?
So 5.
And a is 2. Okay. So in the numerator and denominator, both will apply the same formula. N into a raised to n minus 1. N into a raised to n minus 1. Clear? This you can simplify on your own.
So won't
You,
that just become a different formula?
which formula?
So we can take the top power as n and this bottom power as m. So that can become n upon m into a raised to n minus m.
No, you apply the formula in the numerator, you apply the formula in the denominator. You can express it as n and m. Down you can express it as n and m. Okay, if you don't want to keep it n, you can write m, but then formula application remains the same. So this can be written as 8 upon 5, 2 raised to 7 upon 2 raised to 5 minus 1, that is 4. 8 is 2 cube. So 2 raised to 10, a plus m plus n, okay, indices, minus 4 upon 5. So 2 raised to 6 upon 5, 64 upon 5. This calculations you already know. Here you don't need my help. Okay. Exercise number 4, question number 2. Limit x approaching towards 3, x raised to 5 minus 243 upon x square minus 9. Limit x approaches 3, x raised to 5 minus 3 raised to 5, factorize it, x square minus 3 square. Yes, from girls, can someone tell me what is the challenge in applying the formula?
So there are powers in the denominator.
There are powers in the denominator. So what should be the next step?
So you divide the numerator and denominator by x minus 3.
X minus
3.
3. This time it is 3, na, because a is 3. X minus 5, 3 raised to 5, x minus 3 upon x square minus 3 square, x minus 3. Guys, you are able to understand this? Anyone who is not understanding? Hello.
Yes, sir.
Yes, sir. Yes, sir.
So what is n over here and what is a? In the numerator, what is n? Come on, be quick. Be quick, guys. What is n in the numerator?
1. Sorry, 4.
1.
4,
N
4.
is 5.
So, but okay.
X raised to n minus a raised to n upon x minus a. Okay. Somebody was saying 1, 4. Now that thing is clear. Compare it with the formula. No? Rian, you were saying 1, 4, right?
No, sir.
Somebody said 1, 4. I just want to make sure that person is clear. Nothing else. Chalo, without making any mistakes, please tell me what is n and a in the denominator.
So n is 2 and a is 3.
N is 2 and a is 3. Correct. Fine. So in the numerator, apply the formula. In the denominator, apply the same formula. So boys, can you tell me numerator with how to apply the formula? Boys,
So 2, 3, and 1.
what 2, 3, and 1?
No, so like n is 2, a
Who
is
said n
3.
is 2? Where is n is 2? In the
So,
numerator, n is 5.
acha, I'm talking about the niche wala thing. My bad, my bad, my bad.
Numerator. Arinjay, will you try numerator?
Yeah, so 5 and a is 3 raised to 4.
Correct. Good. Girls, can you apply the same formula in the denominator? Come on. Answer, please. I don't want Anya to answer because she's answering since yesterday. Others, please.
So you will get 3 2 into 3
2,
raised to
3,
1.
1.
2 into 3 raised to 2 minus 1. N into a raised to n minus 1.
So it will be 5 into 3 square, right? Then above, after you cancel the 3s. Can you cancel?
So this will be, yes, we'll simplify this.
Yes.
5 into 3 raised to 4. 2 into 3. So it will be 3 cube, na, Siddhant?
3 cube. Yeah, sorry, sorry. I missed that. 3
So
cube.
this will be 27 into 5 upon 2.
So do you make it into a mixed fraction?
Not required, not really required.
So can you explain how you got 3 cube?
Yeah, so
That's indices. 1 second. 3 raised to 4 upon 3. 3 raised to 4 upon 3 raised to 1. 3 raised to 4 minus 1.
Oh, okay, so got it.
3 cube. Otherwise, directly 1, 3 will get cancelled. No? That's what I've done. Okay. So, Arushi, you are able to understand? Arushi, Aditi, and
Yes, sir. Yes, sir.
okay. Yashvi, what about you?
Yes, sir. Yes, sir.
Rajvardhan,
Yes, sir.
Rishikesh.
Yes, sir, understanding.
Okay, great. So I'll give one problem to solve. Okay. That is question number 5. Question number 5. Limit x approaching towards 5. X raised to 4 minus 625 upon x cube minus 125. Now, rather than me answering, you people tell me. How
So,
should I write the numerator?
so you write x raised to 4 minus 5 raised to 4.
Very good, Siddhant. Upon
And then you x cube minus 5 cube. And then you take multiply and dividing by x by 5, x minus 5, and then continue.
dividing throughout by x minus 5. Okay, good. So I'll divide the numerator and denominator by x minus 5. Okay. Girls, are you clear with this?
Yes, sir.
Yeah. Now, girls, tell me what is n over here and what is a?
N is 4, A is 5.
Perfect. N is 4, a is 5. Boys, tell me what is n and a over here?
So n is 3 and
3.
a is 5.
A is 5. Okay. Yes. Rishikesh, apply the formula in the numerator and tell me.
So it will be 4 into
Mm-hmm.
that is 5 raised to 3.
Correct. 5 raised to 4 minus 1. Perfect. Arushi, tell me how to apply the formula in the denominator.
3 into 5, then 3 raised to 3 minus 1.
Good. Okay. So this can be managed. So this will be 5.
That's 5. So 4 into 5 upon 3.
20 upon 3. 20 upon 3.
So do we write in mixed fraction?
Not a requirement as such. That's fine.
Okay, sir.
Okay, great. Guys, question number 6, take it for self-study. Okay, you can solve it later at home. We'll go to question number 5. Question number 4, sorry. Question number 4. Limit x approaching towards 1, x raised to m minus 1, x raised to n minus 1. X raised to m minus 1, x raised to n minus 1. Okay. Yes, guys, come on. I need your help.
So you can take x raised to m minus 1 raised to m.
Correct.
Uh,
X raised
but
to m minus 1 raised to m upon
upon x minus 1.
x raised to n
Or
minus
1 raised to n.
1 raised to n. Now here also the challenge is the denominator as a power. We don't require denominator with a power. Okay.
So then you divide throughout by x minus 1.
Perfect. Very good. So x raised to m 1 raised to m upon x minus 1, x raised to n 1 raised to n, x minus 1. In the numerator, n is m, a is 1, 1, 1, 1, minus sign, minus sign in between. In the denominator, n is n and a is 1. So Aditi, will you tell me how to apply the formula in the numerator?
So it'll be m into 1 raised to m minus 1.
M into 1 raised to n minus 1, right?
So m minus 1.
Oh, correct. Good. Sorry. Because n is m, na? And denominator, will you go ahead and tell me?
Upon n into 1 raised to n minus 1.
Okay, perfect. Guys, what about this? 1 raised to m minus 1, 1 raised to n minus 1.
So 1 raised to m minus
So
1,
1.
which is 1.
Correct. Good. They are 1. Both the green colored circles are 1. So eventually, the answer is m upon n.
So can we use this like a general formula we were given in class also?
See, this is a derived one. I am not, if your teachers are allowing you do it. Otherwise, don't take a chance. अभी हाँ बोल देंगे वो लोग बाद में marks काटेंगे. I really don't trust.
Alright, sir. Thank you.
Okay. Now there are two complicated problems, and I'm sure if I attempt them right now, you will be able to understand. But then for that, your attention focus should be quite good. Okay. So I'll start with those. Anya, you are marking now.
Yes, sir.
Okay, great. Why Tan is not attending?
So he's got a month today.
Okay. Limit x approaching 0, 1 plus x raised to n minus 1 upon x. Okay. Now mark this problem as important because some things are there which are directly not applicable. Like the formula is not applicable over here. Now there are a lot of complications over here in this particular problem. Okay. Now you need to remember the steps. That's why I'm saying just remember the entire problem in total. Limit x approaching 0. Now first manipulation. This x I'm just writing 1 plus x minus 1. Okay. And this one I'm writing 1 raised to n. So two things I have done. Be attentive. This one I'm writing as 1 raised to n. And this I'm writing it as 1 plus x minus 1. 1 raised to n is 1. And 1 plus x minus 1. 1, 1, 1, we are left with x. So I've given you the reason why we can write it. Okay. Yes. Now can we apply with the formula? Apply the formula over here. This formula is applicable. Yes or no?
Yes.
Yes, sir.
The answer is no. I'll tell you why. N agreed it is there. Minus minus in between agreed it is there. There are no powers in the denominator. Fine. Okay. Then this value x it is same over here 1 plus x 1 plus x. So that is also not a problem. The problem is with only one value and that value is a.
So the limit value.
So this a is it same?
No, sir. It's heading to 0 rather than 1.
No, don't tell me the answer. I'm just asking whether a is same. I want everyone to reply over here because it's a very tricky problem.
No, sir.
No, sir, not.
So a is not same. Otherwise, each and every term can be compared with the formula. So if a is not same, we cannot really apply the formula. Okay, so that becomes a challenge, right? I'm purposely going very slow so that everybody will understand. Okay, now see this. This is a fair step, but write it besides the problem. X is approaching 0. X is very near to 0. We will add 1 to both the sides. Add 1 to both the sides. Why are we adding 1? Because it is 1 plus x. Okay. So we are adding 1 on both the sides. Therefore, 1 plus x will approach what?
1.
1.
1.
Yes.
1. Again. X is approaching 0. Be attentive so that you don't miss out on anything. Okay. X is approaching 0. Add 1 to both the sides because it is 1 plus x. So add 1 on both the sides. So 1 plus x will approach 1. 1 plus 0 is 1. Okay. Now instead of this, can I write this? The answer is yes, because it is mathematically the same. So see, 1 plus x will approach 1. Clear? Clear everyone? What I did in the next step? I replaced this x approaching 0 to 1 plus x approaching 1. Hey guys, you are clear with this or no?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So now can you apply the formula? Limit x
Yes, sir.
approaching towards a x raised to n minus a raised to n upon x minus a. We will analyze a same, power is same, n minus sign is also in place, and here 1 plus x 1 plus x 1 plus x is there. X should also be the same. Na? This value also should be the same. So very well we can apply the formula at this particular point. Hey guys, please tell me. Come on.
Yes, sir.
So now we can apply the formula. Who is n over here? Please tell me.
N
N is n and A is
1.
1. So n into A raised to n minus 1. So the answer is n because this becomes 1. Girls, Anya, Arushi, Aditi, Myra, Yashvi, you understood this?
Yes, sir.
Yes, sir.
Boys, Manan, Rajvardhan, Rehan,
So,
Bansali.
Yes, sir.
Yes, sir.
Yes,
so
sir.
I have a question. So if we have like 1 plus x rather than 1 plus x goes to 1, can we write t goes to 1, 1 plus x equals to t?
One and the same thing. That is one additional step, not really required.
Okay, sir.
You are correct. It is absolutely right, but then not required.
Alright, sir.
So this was your question number 3. Let's go to question number 9. It is also a very similar problem. Question number 9. Okay. Limit x approaching towards a, x plus 2 raised to 3 by 2 minus a plus 2 raised to 3 by 2 upon x minus a. Okay. My first question to all of you. Can we apply the formula which we had been doing?
No, sir.
We cannot really apply the formula over here. Okay. Because here it is x, here it is x plus 2, and again here it is x. So it's a mismatch. Here it is a, here it is a, but then here it is a plus 2. So we really cannot apply the formula. So some manipulations are required.
Not add to what?
Correct. But then when you add 2, you'll have to put it within the bracket. Okay, numerator does not change. So add 2. And why bracket is required? Because minus into plus is minus and 2 and 2 will get cancelled. Yes. So this was the first manipulation. Now guys, tell me, have you understood this particular step?
Yes, sir.
Waiting for your reward. Come on,
Yes, sir.
don't make me call out names.
Yes, sir.
Yeah. Now my next question to all of you. Can we apply formula?
Yeah, you can apply
No,
now.
sir.
No, sir. You have
No,
to
you have
make
to
sure the
change the
limits.
limit.
You have to make sure the
So
limits
A
approach each other.
is not the same.
Correct. A is not the same. X is not the same. This
Add
value
2 on
should,
both sides.
okay. Yes, some students have figured it out, but then just wait for me. Now X approaches A, adding 2 on both the sides. So if X is approaching A, X plus 2 will approach A plus 2. Does it make sense? Yes or no? And this should be mentioned, otherwise your teachers will not give you marks. Whether you like it or not, you should mention this. Okay, so instead of this, I am going to write this. Clear? Is this clear?
Yes, sir.
Okay. Now my next question to all of you. Can we apply the formula?
Yes, sir.
Yes, sir.
Now we can apply the formula very well. Not really a problem. Okay. So who is n? Who is n?
So
Arinjay,
V1.
who
3
is n?
upon 2. 3 upon 2, sir.
Very good. Who is a?
So a plus 2.
A plus 2. Very good, Arinjay. Nowadays you are cooking, huh? Very good.
Thank you so much.
So apply the formula. N into a raised to n minus 1 raised to half. That raised to half you can write root. Siddhant, your understanding?
Yeah,
Yes,
I
Mr.
understood.
Sir, you wrote
Three.
3 upon A. It should be 3 upon 2 in the last step,
Yeah, that is my mistake.
in the
Sorry.
answer which you wrote. You wrote 3.
Yeah. Sorry. Clear? Yes, guys, please tell me.
Yes, I understood.
Okay. Next question.
You won't write 3 root a plus 2?
Yeah, works.
Okay, sir.
Now we are going to exercise 6. Now it's a very simple exercise. It might appear to be very complicated, but then it is absolutely very simple. Okay. Guys, you're clear with this, and girls as well, you're fine with this?
Yes, sir.
Okay, great. Now we are going to exercise 6. It will not take much time. It's very simple. X approaching towards infinity. This problems. Okay. Now what is anything upon any non-zero number upon 0?
So undefined.
Undefined. And what is x upon undefined?
0.
0. Right, Manan?
Yes, sir.
Okay, just remember this. Aditi, Arushi, Myra, clear?
Yes, sir.
Limit x approaching infinity. 4x minus 3, 2x plus 7. 4x minus 3, 2x plus 7. Okay. Now we have a numerator as well as denominator. Correct? Now look at all the x terms over here. So I'll just highlight those for you. So what is the maximum power of x in this problem? Or the degree of x?
1.
1.
1.
Correct. We have to look out for the maximum power. Huh? So divide throughout by x. Okay. Each and every term will be divided by x. Okay. Now this will get cancelled and this will get cancelled. So we are left with this. Now value substitution. Substitute the value of x as infinity. Okay. Yes. So I should ask this to Rajvardhan. What is 3 upon infinity and 7 upon infinity?
So undefined.
Why? You just forgot whatever we discussed right at the beginning.
What?
Anyone else? What is 3 upon infinity, 7 upon
Zero.
infinity?
Zero.
So is it
That's
1 or
zero.
something?
Zero.
It's zero. It's zero.
Yeah. You got the point, Rajwardhan?
Sir, can you re-explain it, please? I didn't get it.
Yes, sir.
X
Same.
0 is not defined. And what is x upon not defined? 0. Any number upon not defined is 0. Any number upon not defined is 0. Guys, you are still confused?
No, sir, I got it. Thank you.
Yeah. So 4 minus 0, 4 upon 2 plus 0. So that is 4 upon 2. The answer is 2. Guys, any issues in this?
No, sir.
Great. Next problem. Question number 2. Limit x approaching towards infinity. 3x square plus 2x minus 5 and x square plus 5x plus 1. Now I'm asking you, girls, can you just reply? What is the maximum power of x in the problem? Maximum power.
Infinity.
No. Maximum power of x.
So 1
Oh, sir,
now.
2,
1
2.
Square, yeah.
It's true. X square, x. So the maximum power is 2, na, Rinjay?
Yes, sir. My
Did
bad, sir.
you understood, na, but?
Yes, sir.
So the maximum power is 2. So divide throughout by x square. So limit x approaching infinity. So each and every term will be divided by x square. Each and every term. Okay. Some cancellations. Okay. So this is 3 plus 2 upon infinity because there is one x left over here. Minus 5 upon infinity square. This is 1 plus 5 upon there is one x left over here. So put x value as infinity plus 1 upon infinity square.
So 1 upon infinity square also will be 0.
Yeah.
So infinity square is just infinity, right?
Yeah. Not defined is not defined square. So what about all these 4 values, guys?
So they'll
0.
be negated to 0.
Negated to 0.
Yes, so because it goes smaller and smaller, right?
So what is negated?
So negligible to 0.
Manan chill, Manan chill.
It is 0. Fine. You might be correct, Manan, in your own understanding. Okay. So 3. Girls, Arushi, Myra, Aditi, Yashvi, you are clear with this?
Yes, sir.
What about boys? Boys, you're fine with this? Hello.
Yes, sir.
Bansali, what about you? Rishikesh?
Yes,
I
I
understood,
understood.
sir. I understood, sir.
Siddharth, Rihan Kanorwala.
Understood, sir.
Yes, sir, understood.
Rihan, the match was too good, huh? First match.
Yeah, sir, we performed really well. I'm happy.
Okay, question number 3. Limit x approaching infinity. X cube plus 6x square plus 1. X raised to 4 plus 3. Okay. Now understand my question over here. Now this is infinity problem. So what is the maximum power of x?
Oh,
Others, what do
3.
you have?
No, sorry.
Oh,
Look in the numerator as well as denominator, not only numerator. So the maximum power of x is 4. So divide throughout by x raised to 4. Okay. So cancellations. X square upon x raised to 4. So this will be 2 or down. Myra, you got this?
yes.
Okay. Now after cancellations, we will try to work on each and every term.
you'll get 0 in the end, na?
This is 1 upon x. Okay. 1 upon x plus 6 upon x square plus 1 upon x raised to 4 upon x raised to 4. X raised to 4 is gone. So 1 plus 3 upon x raised to 4. Each and every term I have written separately for you. Okay. You can write limit over here, limit. All those things you can write over here. And then put x as infinity. Okay. Now what are these values? In green,
So they're all 0.
they are all 0. So this is 0, this is 0, this is 0, and 1 plus 0, that is 1 in the denominator. So 0 upon 1. The green colored values are circles are 0. But then denominator is 1 plus 0, which is 1. What is 0 upon 1?
So 0.
0. So just asking whether you have understood this problem or not. Hello, hello, hello.
Yes, sir.
Okay. Question number 4, I'll just give you for self-study because I want you also to try. So tell me in question number 4, you'll divide throughout by which term? Girls, I want you to answer. Question number 4, which term you'll divide throughout by? Have I given you the image of question number 4? Exercise 6. Those who don't have, should I just send it over the group?
Yes, sir.
Yeah. Just a second. I'm targeting to complete this exercise in this online session. So please bear with me. Exercise 6, question number 4. It's right there in front of you. See, over the group.
You
I
divide
want girls
everything
to
by x cube.
divide through by x cube. Perfect. Divide through by x cube. Let's go to question number 5. It's very simple. Limit x approaching towards infinity. Okay. Now see, there is a square root down. There is a square root down. Okay. And within the square root, there is x square. What is square root of x square, guys?
X.
X. Okay. So the maximum power of x in the problem is this x and this x. This is the denominator. Square root of x square is x. So the maximum power of x is x raised to 1 over here. So divide throughout by x. Divide throughout by x. Because the square root of x square is x. So the maximum power is not x raised to 2 because there is a root at the top. Guys, you understood this discussion?
Yes, sir.
Because there is a root, it's not x square. It is treated as x. Square root of x square is x. So divide throughout by x. So each and every term I'm dividing by x. So this is gone. Now one very logical question I'm asking you. If I want to put a root over here for this x, if I want to just put a root, what should I do? This x, I'm just supposed to put it within the root. What should I do?
The x square root.
Correct. Root of x square. Perfect. So 5 minus 6 upon x. Root of 4x square plus 9 upon x square. See, I'm going very slow. You should ask doubts, please. I took this x within the root. So this became x square. Because root of x square is x. I don't know how many people have understood or not understood.
So we understood. So
Chalo, great. It requires practice. Now this x square. Myra, Arushi, Yashvi, you understood this?
Yes,
Yes,
sir.
Aditi, what about you?
Yes, sir.
Okay, now this x square, I'll just split it in the root. So limit x approaches infinity. 5 minus 6 upon x. Root of 4x square upon x square plus 9 upon x square. Split because there is a plus sign. Now again this x square will get cancelled and we are left with this. Now put the value of x as infinity. Now put the value of x as infinity. Wherever there is x, I'll just highlight it. Put it as infinity. So 5 minus 6 upon infinity, root of 4 plus 9 upon infinity square. So wherever there is x, put infinity. Remaining terms will remain the same. Okay. So this is 0 and root of 4, 5 upon 2.
So over here, you don't consider the plus or minus values of the square root.
No, no, no.
Oh.
Limits don't do that. But then if, sometime back we were finding out some certain values like a or k, something like that. There you
Yes.
have to take plus or minus. But then here, limit final answer, don't take it negative.
Okay, sir.
There are some technical reasons, but then Let's not discuss that right now. Okay. Let's go to question number 6. Let's go to question number 6. Guys, before I proceed, just a feedback from everyone rather. Are you understanding? Are you finding it difficult? Am I going too fast?
No, sir, I understood.
Okay. About others, please tell me.
So we're understanding. So
Chalo, great.
Yes, sir.
Question number 6. Limit x approaching towards infinity. 3x square minus 1 minus root of 2x square minus 1 upon 4x plus 3. Now, guys, tell me if you have understood the previous problem. Okay. Tell me what is the maximum power of x over here.
X, sir.
1.
Correct. It is x, or rather the maximum power is 1. Why not x square?
Sir, because x square, it's under a root. It can't be.
It's under a root. Yes, that's the thing which I was looking out for. It is within the root. I hope everybody is listening very clearly. So the maximum power of x is 1. That is x raised to 1, which is x. So dividing throughout by anyone?
x square.
X by
X
x.
maximum power is 1. So why x square? So divide throughout by x. That is x raised to 1. Every term will have x beneath it. So here there will be cancellation. Yeah. Yashvi, are you there?
Yes, sir. Yes, sir.
Okay. Tell me how to take this x within the root. There is a root, na? So we have to take it within the root. Down also we require a root. So how to write this x?
So within the root.
Yeah, I have to take that within the root. Like the previous problem. Numerator, numerator has a root, na? So I
Yeah.
want to fill that root in the denominator also for this particular x. So how should I write it?
So root of the full thing. So 3x square minus 1 upon x. So the full root.
Is she correct, guys?
Oh, sure.
Okay, so Yashvi, this was there in the previous problem as well. You have to take the full root, na?
Yeah.
So 3x square minus 1 upon x square.
Oh, okay. Okay. Sorry.
Okay, no, don't be sorry, that's fine. But then you got a point.
Yeah, yeah.
You have to
Understood.
consider this within the root. So make it x square, because root of x square is this x.
Yeah, yeah. Understood.
Okay. Yes. How to express this, guys? Can someone tell me?
We will take
The
x square
whole,
inside, no?
we'll take x square inside, correct. So the entire root extends to the denominator and there will be x square inside. And this is 4 plus 3 upon x. There is minus sign over here, sorry. Okay. Now, if you remember the previous problem, this should not be a task for you. Now, within the root, what should I do? Anyone?
Separate the terms and put you cancel and you get 0, na? 3 minus 0 will get.
Good, good, very good. Ansali.
I
3x.
got the answer as root 3 plus root 2 upon 4.
Fine, that's fine. I'm going very slow.
Sir, I got root 3 minus root 2 upon 4.
Okay. So now split,
minus
cancel, 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 cancel. Myra, Arushi, you are able to understand?
Yes, sir.
Aditi, what about you?
Yes, sir.
Now, wherever there is x, put not defined. Okay. So limit x approaching towards infinity, or rather, we are just putting the value and we need to write a limit. So root of 3 minus 1 upon not defined square, root of 3 minus 1 upon not defined square minus root of 2 plus 1 upon not defined square. 2 minus, sorry. And down 4 plus 3 upon not defined. 4 plus 3 upon not defined. Okay. Now these values are 0. Whatever I'm encircling, these values are 0. Anything upon infinity or anything upon infinity square, cube, anything is 0. So this will be root 3 minus root 2 upon 4. Any feedback?
So in
Any
these
feedback,
sums,
guys?
you're not supposed to substitute the values or anything.
We substituted, na? Yeah, we have put
No,
na
sir.
excess.
Like, no, sir. For the root values.
Oh. No, not required.
Okay, sir.
Even if you
Thank
do
you.
it, there is no wrong, nothing wrong in it. Okay.
Yes, sir.
Question number 7. Last 4 questions. Limit x approaching infinity. Root x plus c minus root x. Okay. Now see, guys, there is no denominator over here. Infinity problems, there should be one denominator. Okay. So to get the denominator, we'll rationalize this root minus root thing. Yesterday's class. Okay. Now in the previous problem also root minus root was there. Okay. This problem also root minus root was there, but then it's infinity problem and denominator is there. So I did not rationalize. Okay. But then here in this problem, there is no denominator. So we'll just rationalize this first. So root x, rationalize this. Okay. A minus b, a plus b. So it is a square minus b square. Okay. Copy till here. Now this square and root will get cancelled. This square and this root. Okay. So in the next step, it will be x approaching infinity, root x plus c minus x. Okay. Square and root got cancelled. And down root x plus c plus root x. Okay. So x and this x is getting cancelled. So we are left with c root x upon this. Okay. Yes, now guys, tell me what you should divide throughout with.
Root x.
Now you go to
Divide
denominator.
by root x.
Now you cannot divide throughout by
So divide by
x.
x.
See, the challenge is if we divide by x, okay, every term by x. So whenever this x goes inside, it will be x square then.
Yeah.
Okay. Right. So you just divide throughout by root x this time.
So, but why do we have to do that? Don't we know that root x plus c plus root x is equal to infinity already? So,
One minute, let me think. Then in that case, na Manan, the answer will be what? 0.
yes, sir.
But then the answer is c by 2 over here.
All right, sir.
So see, if you are putting x as infinity, so this will also be infinity. It will be non-determinate, indeterminate form.
All right, sir.
Okay, others please ignore this conversation. Yeah. Yeah, so we were over here. So if you are dividing with x, and when you take that x within the root, it will be x square. So here we are going to divide throughout by root x. Okay. So limit x approaching towards infinity, c root x upon x plus c upon root x upon root x. So divide throughout by root x. So this is 1. This is also 1. And here you have to combine the roots. C upon root x plus c upon x plus 1. Okay, now we are approaching towards the final part of the problem. Yes, anyone? Can you just tell me what to do with this pink colored part?
So, split the
Um,
numerator x plus c upon x. X
Correct.
upon x plus c upon x.
Split this. Split this. So c upon x, c upon x plus 1. X upon x is gone, so this is 1. Now you put the value of x as, anyone? What to put the value of x as?
Infinity.
Infinity.
Infinity. So c upon infinity is 0. Root 1 plus 1. C upon 2. C upon 2. Okay. Let's go to question number 8. Yes, guys, tell me. Those who are attending, are you understanding this?
Yes, sir.
Fine. 3 more problems, then this will get over. Let's go to question number 8. Question number 8, there is no denominator. So what is the first step? Infinity problems. Na? What will we do? There is no denominator over here. Please tell me what should we do?
Rationalize.
We'll rationalize this, correct? So here it is a minus b upon a plus b. A square minus b square. Okay. So now this root and this square is gone. This root and this square is gone. So this will be limit okay, root and square is gone, see, but then keep the brackets intact, and down it will be root of root minus root. I think it should be plus. Okay, this is the plus sign over here. Yeah. So x square is gone. 1 and 1 is gone. So we are left with x upon so the maximum power of x is x, because the maximum power of this x is 1, and the maximum power of x square within the root is also x. The root of x square is x. So divide throughout by x. Maximum power of x is x, because root of x square is also x. So divide throughout by x. Every term should be divided by x. Okay. So this is 1. Yashvi, once again, please tell me over here, if I want to take this x within the root, what should I write?
So x square.
Perfect. Good. So root of x square plus x plus 1 upon x square. Similar concept over here. Numerator में there is 1. So this equal to limit x approaching towards infinity 1 upon x square plus 1 upon x square, x square plus 1 upon x square. Rishikesh, what to do over here now? Are you there?
Yeah, yes, sir.
What to do with this? Anyone? Can you try? Hello, hello, hello.
So do you
So can you
split?
take it? You can
Just
take it
split the
common.
So we put it
denominator.
in like one whole root now.
You have to separate this now. How one whole root? Plus addition of the roots cannot be combined arranged. Okay.
Yes, sir.
So this we need to separate, split.
You take common.
What common? Nothing common. Just split this within the root. So this is 1. This is 1 upon x, and this is 1 upon x square, and this is 1. Okay. Once again, I go back. Sorry. So this is 1 plus 1 upon x. There is 1 x down, plus 1 upon x square. And this will be 1 plus 1 upon x square. How? See this. 1 plus 1 upon x square. What about this, guys? Put x as
Substitute the
infinity.
value of x as infinity.
Correct. Good. Tell me, what is the answer of these circles?
0.
Green color. These are 0. 1 upon infinity, 1 upon infinity square is equal to 0. So 1 upon root 1 plus root 1. So 1 upon 2 it is going to be. 1 plus 1 which is equal to 2. Okay. Let's write a note. Let's complete these two problems as well. Sum of first n. I'll just erase this 1 second. Yeah. Sum of first n natural numbers implies what? 1 plus 2 plus 3 plus dot 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 n. Okay. This can be written as n into n plus 1 by 2. Copy. Sum of first n natural numbers. N into n plus 1 by 2. Sum of squares of first n natural numbers implies 1 square plus 2 square plus 3 square plus dot 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 n square. N n plus 1 2n plus 1 by 6. N plus 1 2n plus 1 by 6. Okay, by the way, this is also written as summation of n. Okay, this is also written as summation of n square. These are different notations. You need to know this. Please copy this. Third note, third and the last note. Sum of cubes of first n natural numbers. 1 cube, 2 cube, 3 cube, up to n cube is equal to n square, n plus 1 the whole square by 4. And it is also written as summation of n cube. It is also written as summation of n cube. Guys, are you still there?
Yes.
Yes, sir.
Yes, sir.
Okay, very good. Thank you. We'll take 5 minutes more.
So
Yeah,
can you go to the previous this thing? I didn't copy the last part.
This one?
Yes, sir.
Let me know once done.
Yes, sir. Done.
Yeah. Question number 9. Limit n approaches infinity 1 plus 2 plus 3 plus dot 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 n upon n square. Guys, what is this 1 plus 2 plus 3 plus up to n? What formula I have given you?
So n plus 1 upon 2.
N plus 1 upon 2. Correct. And this n square, I'll just write it over here. Okay. Now this n and this n is gone. Right? So limit n approaching infinity half n plus 1 upon n. Split this limit n approaching of infinity half n by n plus 1 by n. So n cancel. Now put the value of n as infinity. So 1 plus 0, 1 upon infinity is 0. So this is half. Problem over. You are having any doubts, you may please ask. 1, 2, 3 up to n. Addition of first n natural numbers is this. N into n plus 1 by 2. This n square over here. N square gone. We are left with 1n over here. And n plus 1 in the numerator. Guys, was this easy for you? Provided you know the formula.
Yes. So
Okay, one last problem. Then this will get over. Question number 10. Limit n approaching infinity. Summation n cube upon n raised to 4. Guys, what is summation n cube? What formula I have given you?
So n square into n plus 1 upon the whole square upon 4.
Okay, and n raised to 4. Okay, this n raised to 4 is over here. Now cancellation n square and this will be square. Okay, I will group those squares. This is square. Okay, so 1 by 4. These two squares will group the whole square. Okay, up also square, down also square. So we took a common square. So this is limit n approaching infinity 1 by 4 n by n plus 1 by n, the whole square. Now this is 1. Now what to do, guys? Anyone?
substitute value of n.
Substitute n as infinity.
Correct. Put the value of n as not defined. Clear? This is for everyone. Hello. Is this clear?
Yes, sir.
Yes, sir.
Okay, guys, those who have attended right from the beginning, thank you. And see you in the next class. Bye. Offline.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you,
Bye,
sir.
sir. Thank you, sir.
Bye. Thank you.